Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to Simulink. In this video, we will be looking into the lookup table. In lookup table, specially, we are now looking into the concepts related to the algorithms that are there implemented in lookup table, so that we will have a clear picture which type of algorithm we should be using in which type of application. So basically, if you see the drop down menu for the interpolation, then you will find these 5 types of interpolation algorithms that is mostly being used in this particular type of lookup tables. So the first one is use of line interpolation. So basically this is the one which is represented here. So what it basically does is it uses the formula for determining the next point in a line by calculating the slope. This is the slope part, and you will have the y1 like basically here if you see if you have the graph and you have x1 as the prior point and x2 as the next point. X is the point at which you want to determine the value of your output, which could be y. So over here it is y. You will be having a corresponding value of for x1 it will be y1 and for x2 it will be y2. So those values you need to put here. So this is y1 and this is y2 in the formula, and this is x2 and this is x1, and based on this formula you will be calculating suppose a point in the middle or this point which you want to estimate. So with this line approach you will be able to get the point which you want to determine, which is the y corresponding to this x. So the advantage of this particular method, it is simple and fast and works well for most of the solutions or most of the problems. Disadvantage, it does not work with non-linear data. So if the data is non-linear, then it is very difficult to have this type of interpolation to solve the problem. And yeah, whenever there is also some sharp transitions, there also you will not have a better solution from this algorithm, because it completely depends on the slope and the other calculations. So this is all about the linear point slope. The next one is the nearest neighbor interpolation. So what is done here? So suppose you have the same scenario. Now it will be checked like whether the point in the x-axis, like suppose you have the point x and x1 and x2, so it will be checked like which point it is near to. Like suppose if it is more nearer to x2, you will get the value of y2 in this particular case. So whatever the nearest neighbor, like for x, like in this case suppose if x1 is also like near, then you will choose the y1 as your solution, because x1 is near to x. So this is also very fast when you try to implement it and preserve the original value. So whatever the values that you given on y-axis, those values will only appear in this case. So it preserves your property of the system which you want to create the lookup table for. The disadvantage is it's create bulky and like for discontinuous data it is very difficult to predict and it may give a poor accuracy for smoother data. If the data is very smooth, like it has very close points, then at that moment it will perform not good. So if the data are very close to each other, then in that case it is not a recommended one. Next is the flat interpolation, which is this one in the drop down menu. So if you see here the assigned value like the value will be assigned either from left or to right. That will be fixed whichever the way that you want it to be. This will not give like much accuracy, but yeah, it is very fast, like more fast than the other two, and retains the exact value in the points, like the nearest neighbor one as it is maintaining, and the product abrupt changes, if there is an abrupt change, then yeah, it will not be performing better, and poor accuracy to most real world applications. So this will not perform better, or this will not give you the things that applied to a real world problem. So mostly we try to avoid using the flat interpolation. That is what about flat interpolation. And next is linear Lagrange interpolation. Here, as you have already used like a linear type of equation for determining the points. So here you will be using different type of polynomial, which is also called a Lagrange polynomial. And here, if you see, you have x1, x2. Okay, these are the points on the x-axis, and you have x, which is here being used in the equation, and you have y1, so you will have y1, and you will have also y2, and x1 and x2 are also being used in the equation. So basically this polynomial is y. So basically this is polynomial y, which you are trying to determine. So suppose this is y, so that you want to determine, and in that case, yeah, you can use this technique also, and it provides a smooth interpolation compared to a nearest neighbor interpolation, can be extended to higher order polynomials. So as you already know, like the linear one cannot be applicable for higher order polynomials in like non-linear data. So there, in case of linear Lagrange, you can use to a nonlinear system, and you can increase the order, and you can determine the interpolation. So what are the disadvantages for the same? Can be computationally complex and expensive, because as you are solving an equation, and high order Lagrange polynomial can lead to performance error, or oscillations will be there. So this is the polynomial or Lagrange interpolation, which we see here in the drop down. And the last one is the cubic spline. So cubic spline uses the equation that is represented here, and as you already know, we have x1 x1 and x. So it will just take the point before, like this xi is this point, and it will try to predict using that by calculating the difference, and optimizing it with the help of different coefficients. So basically ai, bi, ci, and di are the coefficients that it is trying to tune, and it can be advantageous to provide a smooth and natural interpolation, avoids like the oscillations that getting created like the Lagrange one, and also ensures very smooth response to the first order and second order derivatives. Like if the system is first order and or second order, it will be very efficient to determine the interpolation output. The disadvantage over here is the computational complexity or expensiveness. So computationally, this type of algorithm is more expensive compared to the other algorithms, and more complex to implement and compared to the linear method. If you want to compare it to the linear method, then it will be little difficult for you to do. But yeah, the most efficient algorithm that you can use for interpolation based on your problem statement, it is not like always this will be the best, but yeah, in general you will have the cubic spline, the most efficient interpolation technique that you can use for any interpolation table or interpolation like 1D or 2D interpolation. These algorithms are same for both 1D and 2D interpolation, and yeah, So for extrapolations also, the same algorithms are in use. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. Have a great day and happy learning MATLAB. Thank you for staying connected.